college algebra class. So what I want to talk about today is rationalizing the denominator. And I didn't see too many of those on the homework. I couldn't find it. So I don't know. We're going to talk about that. We're going to talk about the composition of functions a little bit. So we'll go from there. I'm going to write on the whiteboard a good bit today. So let me go ahead and pull that up. And hopefully everybody can see it. All right. Rationalizing the denominator. What does rationalizing the denominator do? What does it do? That means I want y'all to interact with me. It doesn't mean rhetorical. What does rationalizing the denominator do?
It removes the radical from the denominator of a fraction.
It gets rid of the radical in the denominator. Sometimes they want you to get the radical out of the numerator, but most of the time you're rationalizing the denominator. And when you rationalize the denominator, you have to think in terms of the index. All right? The index is the most important, especially when you're dealing with just a radical by itself, such as x over the square root of 5. All right? X over the square root of 5, what am I going to multiply by? The square root of 5 over the square root of 5. Because our index is a 2. And we all know that the square root of 25 is 5, so that's what we're trying to get. We're trying to get the square root of 25 on the bottom. Now, I do realize that this is an elementary problem, but I'm trying to build up to what you really need to know. So here we've got x times the square root of 5 over the square root of 25, which is equal to x square root of 5 over 5. Okay? Now, rationalizing the denominator is very important when we're talking about limits, because you can't have a radical in the denominator on limits. So you have to get rid of the radical. All right? And that's how you do it. You rationalize the denominator. Also, with rationalize the denominator, you're going to use the conjugate a good bit. So anyway, to make a long story short, what if I gave you x over the cube root of 2? Well, the index has changed. So therefore, you need to think in terms of not squares, but in terms of what? Cubes. So your first cube is 8. So you're going to make cube root of 4 over the cube root of 4. And that's equal to x times the cube root of 4 over the cube root of 8, which the cube root of 8 is what? 2, Hubert. That's right, class. Now, these are two very easy problems, and you're not going to see a lot of these on your limits, but you got to start, you got to crawl before you can walk, and as far as reviewing, you got to remember that you think in terms of the radical, now, or the index. Now, let's step it up a notch, and let's take it to a problem that you might see in a limit. In a limit, you might see something like x over 2 plus 4i. Now, I represents the square root of -1, which means there's a radical in there. And here, whenever you have a radical, whether it's x over 2 plus 4i, or whether it's x over 3 minus the square root of 2. What is needed when you have to rationalize with an operation? Starts with a C. Conjugate. Let's write that down. When you rationalize the denominator, you're going to have to use the conjugate. Conjugate. I have to spell it out when I'm writing it because sometimes it's hard for me to spell. Put an N in it. All right? So, what is the conjugate of 2 plus 4i? 2 minus 4i. Are you the only one that listens in college algebra? 2 minus 4i. What is the conjugate of 3 minus the square root of 2?
3 plus the square root of 2.
All right, finish it. Finish both of them. If you can't, that will decide whether you are a success in life. Well, we've only got a few weeks left before Annabelle opens up. Annabelle comes home. Any Annabelle fans out there? Huh? Yeah. I finally get Mr. Barnes to say something. He says, those are terrible movies. No, they're not. They're good. Mr. Barnes, I'm one of those people that if the haunted house makes a noise, I'm going to go in.
Oh.
I know what kind you are, Mr. Barnes. What are you? I'm going to go. You're going to go out, right? Any horror movie fans in Pendleton or Easley?
Nope.
Nope.
That
I like scary movies.
You like what?
The scary movies.
Well, good. Are you going to go see Annabelle?
I don't know. I don't really like that one.
No, you don't?
Yeah, I like it.
I'll tell you a story. When I was married, my wife had a doll that her mother found, and that doll was one of those 3 or 4 foot tall dolls. Looked like the dang thing looked like Annabelle. It had one of
So
those
you burned it with
porcelain
fire.
faces. Okay, and I didn't know about it. And I come home from work one day, and nobody told me about it. She put that dadgum doll in my kitchen, opens up into a breakfast room. And the breakfast room has all these sliding glass doors and everything and all these windows, so all the sunlight and moonlight comes in. All right? Well, I walk in the kitchen about 2 or 3 o'clock in the morning getting something to drink. All right? And at my house, I'm in the middle of like a 50-acre pasture, so I don't have any lights. So the only light that you have is moonlight unless you turn on the light. So I walk into the kitchen, and if you walk into my kitchen, you walk in and the refrigerator's right here, and to the right is the breakfast room. Well, she put that doll at the head of the kitchen, I mean the breakfast room table, which was facing the kitchen. And you ever go into a room and you see something out of your peripheral vision? Oh my gosh. I actually dropped what I was drinking. I turned, and Annabelle wasn't famous back then. This was around, I don't know, 2000, 2001, somewhere in there. Annabelle wasn't even, that doll had that white face and had that white gown on. And that moonlight hit that white face and that white gown, and out of my peripheral, I turned and looked, and I dropped what I was drinking. Scared me to death. So that's my Annabelle. But I love that movie. Oh, I love that movie. I love the Curse of the Yamo. That was good. The Nun was good. I love all the Conjuring movies. So what's your favorite scary movie, Pendleton? You said you like scary movies. What did you say you liked?
I don't really have a favorite.
You don't have a favorite?
No, not all the scary ones, but I don't like any of the Conjuring stuff.
Well, dadgum.
Like Final Destination?
I love the Paranormal Activity ones. I love those.
Have you seen the Insidious movies?
Yes, I love Insidious. I love those.
So good.
I love Possessions, Haunted Houses, and I love Jason and Michael Myers. And you don't mix horror and comedy. You don't mix those two. Any movie that tries to be funny that's horror, I don't watch. So, You can forget the scary, what do you call it, scary movies? Those are stupid. I don't watch those. All right. Thank you for the interaction, Pendleton. I got 2 people to talk. So I'm making progress here. I hope they don't beat y'all up when y'all go outside in the hallway. Watch your back, because those other 3 or 4 people up there may beat you up. Watch it, okay? Because you talked to me. All right, so here we go. What do we have on the bottom? Oh my goodness, that's shortcut number 3. When you do the conjugate, what will the conjugate always give you where you use it? It will always give you shortcut number 3. I want to tell you a little secret about the shortcuts. Mr. Patel, what's your major going to be later on? What?
Engineering.
Which one?
Computer.
Computer. I was in civil until I figured out I didn't need to be in it. What you want to be in the future?
Going to opera.
Opera? What?
Opera.
Why are you taking calculus?
Because I'm going to just take this and I'm taking the math.
Oh, okay. What do you want to be?
Information technology.
What? Information technology.
Electrical engineering.
Electrical engineering. I had to take the ECT. No, I don't do that stuff. All right, Pendleton, go around the room. What do you want to go into later on with this calculus, since you're taking calculus?
Computer science.
Computer science. How about you, Miss Yabi?
Microbiology is completely unrelated.
Okay, that's all right. You have to take at least 2 calculus, don't you?
Yeah.
Okay. What about you,
Health
Harmon? What's
science.
your last name?
Castles,
Okay. What about you?
health science.
Health science, and you're taking calculus. You going to you doctor school or something?
Yes, sir.
Oh gosh, you're gonna be a doctor. Okay. What about you?
I'd like to do mechanical engineering.
Oh, that's a good field to get into. That's very widespread. All right. What about you?
I'm a senior in biological sciences.
Biological. Oh, so you're finishing up your calculus last, huh?
Yeah.
Okay.
I saved it.
All right. What about you?
Mechanical engineering.
Mechanical. And let's go to easily. What do y'all want to do in the future?
It's just me right now, and I'm doing environmental engineering.
That is a very, very, very good area to go into. Right now, it's all about what? The environment. And you can get a job very easy as long as you got math and science in there. If you have one of these underwater firefighting environmental, they ain't gonna do you no good. But as long as you got math and science in it, if you got environmental engineering or environmental science with a lot of math and science in it, you're gonna be okay. Now, why am I asking you this? Well, let me ask you, Hit. What do you want to go in the future?
Biomedical engineering.
Oh, well, not just medical, he's going to be in school forever. Howell, how about you?
I'm doing architecture.
Architecture. Underwood, how about you?
I'm biology.
Okay, and the other 2, Miss Simpson? Okay, she done passed out somewhere. Okay, who else was here? Who else beside Miss Simpson? Who else is out there? I can't see your names.
Sophie.
Well, I said Miss Simpson. I'm sorry, Miss Wilson. Yes, I transposed the S. I'm sorry. What do you want to go into later on?
I'm a senior bio major.
Okay, so you're already in biology. So my whole point of asking y'all this, the more calculus you take, do you think you're ever going to get rid of the shortcuts? No.
No.
So you might as well get used to doing them. And I usually tell a lot of my first semester calculus, because some of you mechanical engineers and civil engineers, you're going to be taking 3rd semester calculus as well as FEQ, and they're not going away. So what does that give you? Well, here we get x times 2 minus 4i over, well, that's going to give us 2 squared minus 4i squared. And that's going to give us x times 2 minus 4i over 4 minus, and that's going to be 16 times what? I squared is -1, which makes that positive 16, which gives us x times 2 minus 4i over, what's 4 plus 16?
20.
And you'd be surprised on how many people don't get that answer. Same thing down here. X times 3 plus square root of 2. Notice I'm not even concerned with the numerator. Why? Because your whole purpose is to get rid of the what in the denominator?
Radical.
Get rid of the, not the negative, but the radical. Okay? So that's going to be 3 squared minus the square root of 2 squared, which is going to be x times 3 plus the square root of 2 over 3 squared is 9. What is the square root of 2 squared? 2, Hubert. Thank you, class. So that's x times the square root, or sorry, x times 3 plus square root of 2 over 7. Knocking some cobwebs loose? Yes, no, maybe?
Yes.
Yeah.
Okay. So that's rationalizing the denominator. Make sure you understand those two problems because that's you're going to see it in limits. All right, now we're going to move to functions.
Real quick.
Yes.
I was just wondering about this example. Why you wouldn't are you not able to distribute an x to a
Yeah, you can.
imaginary?
Nobody cares about the numerator. Okay. What you're focusing on, I mean, you can do that. You can write 2x minus 4xi. You can do that. That's not a problem.
Okay.
You're focusing on the denominator. So that's fine. That's why I didn't distribute it here. You can if you want to. All right. So next we're going to talk about functions. Now I'm going to talk about functions because some people, not all, forget about functions. And you don't really forget about them because you know how to do them. But functions is just a fancy way of writing what you did in pre-algebra. Back in pre-algebra, or algebra 1 or wherever you learned it, if I told you to take x plus 3 or x plus 3 and add it to x minus 7 or x minus 4, you did, okay, x plus 3 plus x minus 4, and then you went x plus x is 2x, and 3 minus 4 is negative 1. And then if I told you take x plus 2 minus x minus 4, you would do x plus 2 minus x plus 4, because you distribute that negative, and then that's going to be x minus x, that cancels, and 2 plus 4 is 6. Right? Yes or no? Well, can't do that now because you got to be sophisticated. So what you do is you say f of x is equal to x plus 3, and then you do g of x is equal to x minus 4. Now I realize this is pretty simple. I realize that most of you understand how to do this. I'm building up to the composition because the composition functions is where people get screwed up. Okay? Whether you do it, so you're shaking your head, yes. That's where people get screwed up. So I'm building up to that. All right? So for those of you that invented functions, just bear with me. Okay? Just walk on water for a little bit and I'll get back with you in just a minute. All right. So here we just do x plus 3 plus x minus 4. But how is that written? It's written like this. F of x plus g of x. Or it's written, f of x plus g of x. That's the best way to write it. F of x minus g of x. F of x minus g of x. Same thing. You're going to get this right here. What about f of x times? Well, let's go back. Let's erase these. And let's keep these as f of x and g of x. I should have made them all the same. I don't know if I did it or not. But let's say f prime of x, or not f prime of x. Let's go with x plus 3 times x minus 4. You know, the technology that we have, and they have to put this thing right here, right beside, shut up. You use your FOIL method. FOIL method gives you x squared minus x plus what? Or minus what? 12? What's negative 4 plus 3? Something like that. Over here, you would go f of x times g of x, or f times g of x. Is there anything different from the way you did it back in pre-algebra than the way you're doing it now? No. So don't be confused by the function, the f of x and the g of x. That's nothing. But where do students get confused? This is where they get confused. Do you remember back when you solved systems of equations? Everybody remember that back in algebra or college algebra? And you did y is equal to x plus 3 and 2x plus 3y is equal to 6. What did you do with this x plus 3?
Plugged it in.
You plugged it in. What is that called? Substituted, right? Substitution is a 25-cent word for composition, or vice versa. Composition is a 25-cent word for substitution. So you know how to do substitution. It's just the way it's written screws you up. Okay? And I mean this with all sincerity because a lot of students, I taught a lot of classes in college algebra and what's called Math 102. And a lot of students would do Math 102 and they would do composition and they'd go, oh yeah, this is easy. And then they would go into Math 110, which is college algebra, which is one above, and the teacher would explain them how to do compositions and they totally wouldn't know what to do. Is it the same thing? Yes. The way it's explained confuses a lot of students. All right? So here I do F composed of G, fog. Now, when you see F composed of G, the F means right with B, A, parentheses. Okay? That F, you're going to rewrite that F with BA parentheses. So how do you rewrite F? F is what? X plus 3. So that means I'm going to rewrite F with a big set of parentheses. What does the G mean? G means that I'm going to plug G into what? F.
The F function.
And then I'm going to plug G right in there. And now you've got substitution that you did back in pre-algebra. But you'd be surprised on how many people, when I put F composed of G on a test, they just sit there and what? Stare at it. So X minus 4 plus 3 is X what? X minus 1. All right, now do G composed of F. G composed of F. Do that one. F of X is equal to X plus 3. G of X is equal to X minus 4. So I'm going to rewrite G with BA parentheses. So that means parentheses minus 4. And what am I going to plug in? Plug in F. And that's going to give us X minus 1. Now that's just a coincidence.
Because the order of operations is the same.
What order of operation? What are you talking about?
So because it's just on the same level of the order of operations.
Well, it's just a coincidence that the numbers comes out to be X minus 1.
Yeah.
It's just, yeah, that's just a coincidence. A lot of times it doesn't happen to be a lot of times it doesn't come out to be the same. Sometimes it does, sometimes it doesn't. Okay, now you've done F of G, you've done G of F. Now what else is there you can do? What else can you do with these two functions? That means I'm interacting with y'all. That means I want y'all to interact with me. Unless you just don't have a clue. Somebody want to elaborate and tell me if they don't have a clue or they just don't like me? Which one is it? Because if you don't like me, I can take care of that. I can put smokestacks on my truck, and that'll take care of that. Or wear sunglasses inside. Y'all just hate me, don't you? Is that what it is? Why do y'all hate me? Why is it? I mean, have I done something to y'all? Mr. Swords, are you still there, or you just left?
I'm here.
Why do they hate me, Mr. Swords?
I don't know. I can't figure it out.
Something in that Pendleton water up there. Well, it's starting to spread easily. I'm starting to think y'all hate me too. I know Mr. Barnes don't hate me because he's had me for several classes, so I know he don't hate me. He just don't talk. But I have a hard time believing that 7 or 8 people don't talk. I have a problem with that. I think y'all just don't like me. I think that's it. That's all right. I'll go out and buy me a $1,000 car and put $10,000 worth of rims on it. That way y'all like me. All right, so what about F composed of F? What is F composed of F? I'm going to rewrite F with a big set of parentheses and do what?
X plus 3.
Plug in F. And that's going to give me X plus what?
6.
And what's one more that I can do?
G of G.
G composed of G. Do that one. I'm going to rewrite with X minus 4, and I'm going to plug in X minus 4. And that's going to give me X minus what?
8.
So people don't have a problem with adding or subtracting. People have a problem with composition of functions when you actually, people have problems with functions when they ask for you to compile. And compile or composition basically means substitution. Anybody ever had trouble with composition of functions? Okay, then y'all got it down. Everybody got it?
Yes, sir.
Okay. Now we're going to go. I've covered a lot of what the homework covers. Now, somebody sent me a homework question. I saw it. And there's nothing wrong with the person that sent it. But that question is really not a good question. Okay? I will show it to you as soon as I can figure out how to present it. Okay? The question, who sent that question? Anybody remember seeing it? It's 1.1. Okay? Well, you don't have to say anything because it's not a good question. And I can understand why you were a little bit confused on that question because it is not a test question I would put on a test because it's one of those questions where they ask you something and they don't give you enough information to go off of. Okay? I give you questions that, the questions that I cover in class are the type of questions I give you on the test. I don't do those questions, what is F of 3 composed of 5? And they don't give you anything except a chart. Okay? That's not what I do. Okay?
Yeah.
Yes. Somebody say something?
I said, oh, that was me.
Okay, you know what question I'm talking about?
Yeah, that question sucks.
Yeah, that question is not a question I would give on a test. In fact, this is a new book we're using, okay? Everybody with me? And this is the first time I've seen that question. I'm trying to figure out how they're actually doing it. So that should tell you that it's not a good question, if I'm having to figure it out. So,
was it the one with like the matrices, and then you had to follow all the different functions, and you like had to like...
No, they didn't even give you a matrix. They gave you a table, and it had like f of x.
Table chart, but it didn't include the value you needed to begin with.
It's very vague, and I'm going to have to figure out how to present it because I've never seen that question before in my life.
Do you remember?
It was like 1.1, and it was one of the questions where it gave a chart, and you have to follow f of g to the correct value, but it didn't have
I'll pull it
the
up.
starting value to begin
It was
with.
like question 6.
I'll give it to you, Mr. Mr. Swords, and you can do it on the test.
All
How
right.
about that?
That seems fair.
Yep.
Yeah, I think so.
Here's question number 8.
Oh, somebody done sent me some more questions. That's great. Thank you. Here it is. You have a right to be confused with this question because this is a question I would never give on a test.
I know how to
Okay?
solve that. Finished it.
This is ridiculous. Okay? I wouldn't even give this in a class because it's very vague and some of the questions are pretty simple. Like f of g of 1, -1. F of g of -1 is 3. Okay?
I can explain it because I actually finished it.
No, that's fine. That's fine.
Okay.
I'm still working on it. And that's fine. I
Okay.
appreciate it. But this is not a question I would give you on a test. I would give you the actual functions. I would say f of x is equal to 5 minus x, and g of x is equal to 2 minus or 2 plus 4, or x plus 4. And I would tell you to find f of g of -1. To me, that makes more sense than this. Okay? So I'm not ignoring your question. I'm ciphering over it. But I'll look at these 2 questions. I just saw these. These were just sent today, I believe. So let's look at them and see if if we've covered them yet. This is algebra review question number 22. Let's see if they're asking if this is a good test question or not. Oh yeah, this is a great test question. All right, write an equation, and this goes right to where I'm going today. So you did good sending this one. It says write an equation of the line of the given point perpendicular to the given line. The first thing I'm going to tell you to do on this problem, I show students how to do this with a parallel and a perpendicular line at the same time, because you can use the practice. Practice makes what? Have you ever tried to play the piano and you suck at it? That's why you sucked at it, because you didn't practice enough. Same thing with this. So we're going to draw a big table. And I'm going to put a line there. I'm going to put a line here. And I'm going to put my 6x plus y. I'm going to put that right here. 6x plus y is equal to 4. And I'm going to put parallel lines, and then 8, 9, and then perpendicular line 8, 9. Oh, I can't chew bubble gum and write at the same time. That's all right. I'm a guy. I'm covered. All right. What's the first step? The first step is you solve for y. So 1, solve for y. So y is equal to -6x plus what? 4. 2. What is m? M is equal to what? -6 over 1. Therefore, for a parallel line, what is your m going to be on your parallel line? Is it going to be the same? Yes. Now you've got a point and a slope, you can use a point-slope equation. What is m on a perpendicular line? The opposite inverse, or the opposite reciprocal. Sorry, not the inverse. The opposite reciprocal. So what's the opposite of negative?
Positive.
Y'all are just on the ball, I'm telling you. Positive. And then what is the reciprocal of 6 over 1? 1 over 6. Now you're ready to do parallel and perpendicular. So go ahead and do that. You've got a point and a slope. I do all of when I teach my students, I don't care if you're in pre-algebra, algebra, whenever I'm teaching this, I always teach to do the parallel and the perpendicular. So therefore, when you ask the question, you can do it without any problem. It takes a little bit extra what's that word? Work. Yeah. Heaven forbid we work extra, we do extra work. Oh me, what would we do without work? Have underwater firefighting majors. Okay. So y minus 9 is equal to negative 6 times x minus 8. Y minus 9 is equal to 1/6 over x minus 8. Y minus 9 is equal to negative 6x plus what, 48? And y is equal to negative 6x. What's 40? What is 48 plus 9? Dang old 57? So that is your parallel line and your perpendicular line. Oh crap, we might as well stop on this one. Why? Why are we going to stop?
Fraction.
A fraction. We can't do fractions. I don't know what's wrong with this pen. It's just going crazy. Okay, what's negative 4 plus 27? Dang old 23? Y'all check my math because this pen messed me up. Y, like the Russians, 1/6x, what'd I say, 23? Somebody check my math. So now you've got not only the parallel line, but you've also got the perpendicular line. Isn't that neat? You feel better about yourself? Okay, nobody's going to talk to me. It's time to not talk to Hubert. I'll just check it on the machine because y'all won't talk to me. Because y'all hate me. Negative 6x, what'd I say, plus 57? Okay. That means I'm not typing it in right. What? Oh, it wants perpendicular. Okay. 1/6. Let me just go 1/6. So I got to type in. Oh, whatever. 3. Final. There we go. What's the answer? 1/6 plus 23/3. There we go. How we feel on that one?
Much better.
Thank you. All right, so that's that one. What's this one? This was number 4. This is the next one, so I'm just doing y'all's homework for you. Okay, I see how it is. Now this is from 2 different people, so I can do that. This is number 38 on the review 4. Solve by completing in the square. This is a test question. You better believe anything completed in the square is going to be a test question. I'm not even going to worry about the directions. I want to do the whole thing. Because I don't want to suck at calculus. 6x second plus 17x plus blank is equal to 14 plus blank. Factor out of what? Good job. You're the one that listened. X squared plus 17/6x plus blank is equal to 14 plus 6 times blank. Well, now we might as well quit here because we got a fraction. So I'm going to go over here and I'm going to take 17 over 6, divide by 2 over 1, and square it. Well, I don't divide by 2 over 1. I multiply by what? 1 over 2, Hubert. 17 over 6 multiplied by 1 over 2 squared. And that's going to give us 17 over 12, quantity squared. Now, dang old 16, we said that was what? 256? What is 17? 343? Somebody do 17 squared. What do you get?
289.
289, sorry. Okay, so that's what we're going to add on both sides. So that's 289 over 144. 289 over 144. On this side, that gives us shortcut number 1. So that's going to give us 6 times x plus 17 over 12 quantity squared is equal to 14 plus 6 over 1 times 289 over 144. Well, I know that 6 will go into 144 because 12 will go into 144. So, how many times will 6 go into 144? 2 and 4, right? 24?
Yes.
Thank you. And then that's going to change. What's 24 times 14?
336.
So let's change that to 336 over 24. So that's going to give us 6 times x plus 17 halves, or 12, quantity squared, is equal to, what is 336 plus 289? 6, 1, 6, 2,
625.
625. Oh, I like that. That's such a nice number. Because that 6 is going to make this, that's going to be a perfect square. They're going to work out right. All right, keep going. What's our vertex? Let's go ahead and get our vertex because our y-intercept is negative 14. Y-intercept is negative 14. Let's go ahead and get our vertex. Somebody divide 17 by 12. Dang old 1 and 5 twelfths, that's almost 1.5. What does it come out to be? What's 17 divided by 12?
1.4.
1.4. And then 625 divided by 24. What does that come out to be?
26.
26 even?
26.04.
26.04. There's our vertex. All right, now finish it. Divide by 6 on both sides, which means you're going to multiply by what? 1/6, which is going to make that 24 times 6, going to make it 144, which means dang old perfect square. I'll let y'all finish it. I want you to graph it. I want you to tell me the domain, the range, increasing and decreasing values, and the line of symmetry. Because if you can do that, you can pretty much handle anything dealing with completing the square. What time's class over?
4:25.
I don't understand why this class goes by so fast. Like, it's over in like 30 minutes. Maybe because I'm doing the math. Maybe that's why. That's okay. That'll leave the first. Let's say we don't meet tomorrow. So that means I can start the calculus next week. That's what I want to start. I want to start with the, the transition with limits and slope. That's what we're going to be doing. We're going to make a transition next Monday and Tuesday. Dang old puberty. Dang old transition. Transition from what? Calculus. Transition from algebra into what? Calculus. And how do you do that? You take algebra and you add the limit theory to it. And when you add the limit theory to calculus, it's like adding chocolate powder and milk. You get chocolate milk. You add the limit theory to algebra, you get calculus. Actually, like I told you before, 10 to 20% of your calculus questions are calculus. The rest of it's algebra. That's why people suck at it. So I'm going to divide by 6 over 1. If I divide by 6 over 1, I multiply by 1 over 6, which will give us that magical 625 over 144. And why is that magical? Because it's a perfect square. So x plus 17 twelfths is equal to, squared, is equal to 625 over 144. Take the square root of everything, and that's going to give you x plus 17 over 12 is equal to, positive or negative, what's the square root of 625? 25, isn't it?
Yes.
Thank you. Over 12. And then x is equal to positive or negative 25 minus 17 over 12. Well, what's 25 minus 17? Hubert.
8.
It should be. Isn't it 12? Or is it 8? Is it 8?
It's 8. Yeah,
8 over 12 comes out to be what?
3/4.
3/4? No.
2/3.
2/3. That sounds better. So my 2/3 is one x-intercept. What's negative? Oh, I'm looking at the wrong one. That's why I couldn't get it. I'm looking at this one. I'm supposed to be looking at this one. I was looking at the one before it. Sorry. Okay, negative 25 minus 17 is negative what? 42? Somebody help me out there. What's negative 25 minus 17?
Negative 42.
Negative 42, go ahead and divide that by 12. Well, we'll just simplify it. 6 will go into both. What? 7 halves? Somebody check me out. 7 over 2. What is negative 42 twelfths? Does that come out to be 7 halves?
Yes.
Okay, now plot those points. Who's got a question so far? Now, what they're asking for, of course you can't tell it because they like to talk in big terms. They're asking for the x-intercepts. So that's what they're asking for. But we're going to keep on going because I want to show you what we're doing. So I'm going to take my handy dandy eraser and I'm going to erase all of this. And I'm going to draw a big A graph. And 0, negative 14's down here. Negative 1/4 and negative 26 is down here. We've got 2/3, which is 0.67. And we've got negative 3.5. It's open and upward. And that means we've got domain is all real numbers. Range is from where? Negative 26.04 to infinity. Negative 26.04 to infinity. And then our decreasing is from negative infinity to negative 1.4. Remember, when you're going increasing, decreasing, at this point it's neither increasing or decreasing, so you do not put a bracket here. Increasing from negative 1/4, negative 1.4 to infinity, and the line of symmetry is what? X is equal to negative 1.4. Does that help with you on the complete the square? That one is about a 9 or a 10. So don't feel bad about having to ask that question because I expect that. Not a lot of people can do 9 or 10 completing the square without some help. So you're doing okay, unless you walk on water. And I ain't seen too many people walk on water, so.
There's a couple of lizards that can walk on water.
Yeah, I know. There's a couple of bugs that can too, but they're not people. Let's see if I got the answer right. That way I won't have to wear sunglasses in the gym. What'd they get? 7 halves and 2/3. Look there. It's a miracle. Or carry a jug of water, a milk jug full of water around. You ever seen people do that before? All right. So that takes care of those two. Let me show you what we're going to do next week, and I want to show you. And this This is, I can't believe it's already 4 to 10. I can't believe that. I think y'all doing something to my clock. All right. I'm going to draw a picture on the board, and I want you to tell me how to find the slope. Got a curve. And if I join those two lines, show y'all a trick I learned in the war. If I join those two lines, that's called the secant line. Why is it called the secant line? Anybody know?
Because any 2 points on a circle of 5, the line between any 2 points.
Okay, I gotta sit down. I'm not used to somebody answering that question. Yes, it's on the inside of the circle. Okay. Now, in engineering, especially in civil engineering, when you go through hydrology or you go through some of the courses in transportation, that's called a chord. Okay, because that's the intersection of 2 points on a curve, on a horizontal curve or vertical curve. Secant line, chord, whatever you want to call it. But the whole point is, how do you find the tangent? How do you find the slope between 2 points? Well, this is y sub 1. This is what? X of 1. This is what? X of 2. And this is what? Y sub 2. And what's the formula for slope? Delta y over delta x. What's that? Y sub 2 minus y sub 1 over x sub 2 minus what? Everybody with me? Yes or no?
Yes.
Yes.
Okay, everybody understands that. That's your algebra. That's your pre-algebra. That's your algebra 1, your algebra 2. Then what's going to change? Well, I'm going to throw the limit theory in there. Now, the limit theory basically says a bunch of gobbledygook, but I want to explain this a way that you understand. Let's say this is a wall. Okay? And you are standing over here. And here's the floor that goes to the wall. And let's say you have a stride of 4 feet. Everybody with me? And my directions to you are to take a step toward that wall, but only take half of the previous step. Everybody with me? So what will the next stride be? 2 feet. What will the next stride be? 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 You're not supposed to know that. Everybody gives up after the 4th. What's after that? 16th. Will you ever reach the wall? No, you will not reach the wall. That's the limit.
I saw a cool video on this where the guy, where they're doing that, but it was the ant, where they would have a rubber band, and they had the ant walking at a steady pace the whole time, but then the band was also being infinitely
stretched.
Mm-hmm. And so even if it was the ant would exponentially speed up.
Okay.
But it was a steady, so he would gain infinitely towards the end, but he would never hit the end.
Yeah, it's the same concept.
Okay.
You realize you're interacting with me. You're not supposed to do that. Pendleton, don't beat him up, okay? Don't go at Pendleton. They'll beat you up. They will hunt you down and beat you up.
It looks scary.
Yeah, you're not supposed to talk. All right, so what does this say? This says basically that you take half a step, you half a step, this distance will always converge to what? It will always converge to 0, but will it ever reach 0? No. Now, what does that have to do with this algebra that we're doing? Well, we're going to take that algebra. We're going to take this right here. I'm going to color this red. I don't use red a lot because I don't like it. It's a negative color, and I don't want any of the buttercups or the snowflakes to, take it negatively. Okay, but going to 0, that's the limit theory. Put in your head, limit theory, x approaches 0. Okay, your distance approaches 0. We're going to change some of this nomenclature here. All right, we're going to call this x. I'm going to write this in blue. We're going to call this x. And of course, after you get out of pre-algebra and algebra 1, you can't be a redneck anymore. You have to hold your pinky up, and you can't call y. You have to call it what? F of x. Okay? Now here's where we're going to put this red in. The red between x and the second one, the second x, is called h. You can call it d. Some people call it d for distance. I don't know where h comes from, but horizontal distance, I don't know what you call it. But we're going to call that h. Everybody with me? So this would be x plus what? This point right here would be what? X plus h. Of course, we can't call this y sub 2. We have to call it what? F of x plus h. Buffy, f of x plus h. Everybody with me? Now I want you to figure the slope, taking out those old redneck terms, y sub 2 and y sub 1, and I want you to put in the sophisticated terms. Do that right quick. So what was y sub 2? F of what?
F of x plus h.
Minus, what's y sub 1? Over what?
H.
X plus h
X.
minus what? And what happens to the x's on the bottom? So now we have the slope is equal to f of x plus h minus f of x over h. Anybody ever seen this before? This is called the difference quotient. Say again?
Difference quotient.
Difference quotient. Difference quotient is a pinky term for what? A pinky term for what? The slope. Now is where we get to the good stuff. We're going to go through the puberty now. We're going to go through the transition. I'm going to, instead of going this way, I'm going to bring this distance down to 0. Let me change this to green. This distance, this point right here, I'm going to bring down to this point. Remember the wall? Take half of the step. Here's the wall right here. Everybody with me? So basically, this is going to what? 0. Everybody with me? Now what happens when I bring that to 0? What is this line doing? This point is coming which way?
Downward.
Downward, like this. Do I touch this black dot? No. Think of a 200th of a hair. You gotta think out of the box. You're thinking a hair, the width of a hair between that black dot and that green dot. So the secant line turns basically into what? Doesn't start with a S, it starts with a T.
Tangent.
What? Tangent line. So, what I do to get the equation for the tangent line, the green line, is I apply the limit theory, limit, as h approaches what? And I put the limit theory with the slope, and you put those two together, and this gives you the derivative. Now that's where you're heading with this. Now, we're going to do some Monday, we're going to do some limit theory, we're going to do some of that Monday. But that's where you're heading. But if you can't do the algebra, then we're in trouble. So basically, what is your first thing in calculus going to be doing? You're figuring the slope that you did back in pre-algebra and algebra 1. I can't believe it's already 4:25. Y'all know why time goes by so fast? Because I love y'all. Because y'all so interactive and so talkative. Y'all suck. Hey, I got some kind of interaction out of you. Y'all remember Peyton, huh? I showed you all the video of Peyton, right?
Oh, yeah.
Yeah.
So funny.
Swan and Delta.
Who's sitting in the porta potty?
So like very.
Yeah, that video wouldn't make it now. Somebody get offended.
You might be right, actually.
All right, I don't know who this is first. Who is this?
That's funny because like I dropped.
Okay, this is Pendleton. Okay, Pendleton, listen up. Bryson.
Here.
Like,
Castles.
Here.
Greco.
Here.
Gusmus is there. Howell's here. Jones. No Jones. Underwood.
Here.
Williams.
Here.
And Miss Wilson is here. Okay, Pendleton, if you don't have any questions, have a good weekend. See you Monday. If you do have questions, stick around. Next is, I don't know who. Okay, this is Anderson. Okay, Barnes is here. Brock. Iyabi is here, sorry. Patel is here. Rudiger, did you ever show up, Miss Rudiger? I don't think she did. Nope. And Story. All right, y'all have a good weekend. If you got questions, stand by. And the last one is, of course, Easley. How many up there, Easley? 2?
Yeah.
Okay, no, Miss Rowland's here. Miss Rowland's there, so let me just hit. So the only one not there is, no, Hit's there too. Okay, everybody's there. So y'all have a good day, and if you got any questions, holler.
Oh, cool. I was just trying to get this out of the way.